When we type a message on a computer, we see letters, numbers, and symbols, but the computer does not store these characters directly. Instead, every character is first assigned a numerical code. That numerical code is then converted into binary. In this example, different characters, such as letters, digits, and symbols, are transformed into streams of binary digits. Those binary patterns are what the computer actually stores, processes, and sends to other devices. Later, when the data is read, the binary is converted back into the original characters, so we can read the text on the screen. This simple process allows computers around the world to store, process, and exchange text accurately and efficiently. When you type the word hello, the computer does not store the letters themselves. Instead, each character is assigned a unique numerical code. For example, the letter H becomes 72, E becomes 101, and the exclamation mark also has its own code. Next, each number is converted into binary. These binary patterns are what the computer actually stores and processes. The binary data then travels into the computer's memory, where it can be processed, saved, or transmitted to another device. Although we see readable text on the screen, inside the computer, everything is represented using binary digits. This is how computers store, process, and communicate all text information. Computers work with many different kinds of characters. A character is not just a letter. It can also be a digit, a punctuation mark, a mathematical symbol, or a currency symbol. For example, a, we, 7, at, and pound are all individual characters. Even though some characters may look similar, each one has its own unique identity. Uppercase A and lowercase a are different characters and usually have different character codes. Every character is assigned a unique numerical code before it is stored as binary. This allows the computer to recognize, store, process, and display every character correctly.
Computers can recognize many different types of characters. These include uppercase and lowercase letters, digits, punctuation marks, mathematical symbols, currency symbols, and even spaces. Although these characters look different, the computer treats each one as a unique character. Every character is assigned its own numerical code inside a character set. That unique code is then converted into binary so the computer can store, process, and transmit it. By assigning a different code to every character, computers can display text, symbols, and numbers accurately and consistently. At first glance, uppercase A and lowercase a may seem like the same letter. But to a computer, they are two different characters. Because they are different characters, each one is assigned its own unique numerical code. In this example, uppercase A has the code 65, while lowercase a has the code 97. These numbers are then converted into binary. Uppercase A becomes 01, 000001. Lowercase a becomes 011, 00001. Although they represent the same alphabet letter, the computer stores them differently. This allows software to distinguish between uppercase and lowercase text and display each character correctly. Although they look the same, the character 7 and the number 7 are not the same thing. The character 7 is part of text. It has a character code and is stored using a character set. You might find it in a phone number, a password, or a document. The number 7 represents a numerical value. It is used in calculations, such as 7 plus 3 equals 10. Because they have different meanings, computers process them differently. A digit used as text is stored as a character. A number used for mathematics is stored as a numeric value. Understanding this difference is important when working with data and programming. Did you know that even a space is a character? In the phrase, "Hello world," the space between the two words is not empty. It has its own character code. Just like every letter, the space is assigned a numerical value. That value is then converted into binary. When the computer reads this binary code, it knows exactly where to leave a gap between the words. Without the space character, the text would appear as "Hello world," with no separation. So, letters, digits, symbols, and even spaces all have unique character codes that allow computers to store and display text correctly. A computer cannot understand letters and symbols by their appearance alone. Instead, it uses something called a character set. A character set is a collection of characters where each one is assigned a unique numerical code. For example, the letter A has its own code. The digit 1 has a different code. Even symbols, punctuation marks, and the space character all have their own unique codes. Once a character is assigned its numerical code, that number is converted into binary. The computer stores and processes these binary values instead of the actual characters. This organized system allows computers to display text accurately and communicate correctly with other devices.
Every character inside a computer is assigned a unique numerical code. For example, the letter A is assigned 65. The letter B becomes 66. The letter C becomes 67. Symbols, such as at, and, also have their own unique codes. After each character receives its numerical code, the number is converted into binary. These binary patterns are what the computer actually stores and processes. Although we see letters and symbols on the screen, inside the computer, everything is represented as binary digits. This simple system allows computers to store, display, and exchange text accurately and consistently. Let's see how a complete word is stored inside a computer. Here, the word cat is made up of 3 separate characters. Each character is first assigned its own numerical code. The letter C becomes 67, the letter A becomes 65, and the letter T becomes 84. Next, each number is converted into binary. The computer then combines these binary values in the correct order. This sequence of binary digits is what the computer stores in memory. When the data is read later, the computer decodes each binary value back into its original character. That is how the simple word cat can be stored, processed, and displayed accurately using binary.
Now let's see how a character code is converted into binary. Suppose the uppercase letter A has the decimal code 65. To convert 65 into binary, we use the 8-bit place values. We ask, which place values add up to 65? The answer is 64 plus 1. So, we place a 1 in the 64 column and another 1 in the 1 column. All the other positions become 0. This gives us the binary value 01, 00001. So the character A is stored inside the computer as 01, 000001. This simple conversion allows every character code to be represented using binary, so computers can store, process, and transmit text accurately.
After a character is stored as binary, the computer must be able to turn it back into readable text. This process is called decoding. Here, the computer reads the binary value 01, 00001. It converts the binary back into the decimal number 65. Next, it looks up 65 in the character set. The character set tells the computer that 65 represents the uppercase letter A. Finally, the software displays the letter A on the screen. Without the character set, the computer would only see a binary number. The character set gives that binary value its meaning, allowing us to read understandable text